Hello, everyone. So, today, after the introduction to semiconductor physics, we are going to start the diode. So, in our previous discussion as well, we started with this acknowledgement that AI is used, and this is the reference book which we are going to follow. Uh, the introduction to semiconductors is already discussed. Now we will start with the diode, its operation, diode characteristics, then how diodes are used in rectifiers, in power supplies, and some of the special purpose diodes. So let's start with the PN junction. In our previous lecture, we discussed that a P-type material is formed when a trivalent impurity is added, and a N-type material is formed when a pentavalent impurity is added in pure silicon or pure germanium. So if we take a block of now silicon, dop half of it with trivalent impurity, so this will be P-type material. Other half with a pentavalent impurity, this will be an N-type material. And now this boundary will be called PN junction, where these both type of materials are meeting and will result in a semiconductor diode. That will be actually a diode. So P means where the majority are holes and minority is of electrons, and N means where majorities of electrons and holes are in the minority. So this will be the junction like this. There will be some P region, there will be some N region and a PN junction, and it's actually the diode. So the diode word comes from the combination that is di means two, ode or electrode. Ode means electrode, R terminal. So there are two terminals or two electrodes, namely anode positive and cathode negative. So when this junction is formed, at that instant, free electrons in the N region near the PN junction begin to diffuse across the junction and fall into the holes near the junction in the P region, just like shown here. So after this, there is a formation of depletion region in the diode, because as electrons diffuse into the holes, so a region, namely depletion region, is formed at the junction. So for every electron that diffuses across the junction and combines with a hole, a positive charge is left in the N region because electron has left the N region. So positive charge is on the N region side, and a negative charge is created in the P region because electron has acquired this position, and this results in a barrier potential. So basically this region is called depletion region, and this region acts as a barrier, as a hindrance to flow of current, and the voltage or potential is developed across this is called barrier potential. So this section continues until the voltage of barrier repels further diffusion. So this process is continuous until and unless now at this side there is negative charge. So this will not allow any further electrons from this same region to diffuse in the P region. Similarly, this positive charge will not allow any of the holes to move from P region to N region. Now, this barrier potential labeled as VB, actually this is the voltage. So this is the amount of voltage which is required to move electrons through the depletion region. So this is the potential, the amount of voltage which is required to break the barrier or to overcome the barrier. And this is standard as 0.7 volt approximately for silicon and 0.3 volt for germanium. Although it's less for germanium, but we know still silicon is more used because of the thermal stability. So as the junction temperature increases, this potential decreases and vice versa. So that's why silicon is more stable against higher temperatures and it's most widely used. And this is the voltage that must be overcome for current to flow. So if we want to flow the current through the diode, so this potential barrier or barrier potential must overcome so that current could flow through the diode. We are going to discuss this in more detail. So now what is a diode? It's a semiconductor device that allows current to flow in only one direction. This is actually the characteristic of the diode, that it allows the current in one direction. However, it blocks the current in other direction. And we will see in few moments that in which direction it allows the current and in which direction it blocks the current. So if we talk about the main parts, there is a P region, a N region, and the junction region. If we talk about its applications, they are used in rectifiers. Rectifiers are those which convert AC to DC. Similarly, power supplies and for the applications of signal detection. So we will use the process of rectification and as well as how they are used in power supplies. This is more or less same. We will not go for the signal detection because that is not our focus in this subject. So now there is a term which is called bias. So what is bias? In electronics, this term bias refers to the use of a DC voltage to establish certain operating conditions for an electronic device. So when this is applied, the term is named as biasing. So biasing means when we supply DC voltage to some electronic device. So provision of DC voltage is called biasing. There are two practical bias conditions, forward and reverse. And we will see now that in which condition this is forward and in which condition this is reverse. So either of these conditions is created by application of sufficient external voltage of the proper polarity across the PN junction. So basically forward and reverse is the polarity, nothing else. So we will see in few moments which is forward bias and which is reverse bias. So biasing a diode, when we apply forward bias, so forward bias is that condition in which current is allowed through the diode or current flows through the diode. So this is diode. This is a resistor, external resistor for limiting the current. This is the bias voltage. Now bias voltage is such that plus is connected with P side, minus is connected with N side. This condition is forward bias. So in this case, what happens? The plus side attracts the electrons from the N region and results the current flow after breaking this barrier. So we can see its illustration from this. This we will also do in our hardware lab experiment. So now what we have done, we have connected a voltmeter across the supply voltage, which we are calling as bias voltage, another voltmeter across the diode, and an ammeter for measuring the current. So at this time, there is no bias voltage R0. So similarly, there is no voltage across the diode, no flow of current in the circuit. Now, we have applied some forward bias voltage, but it is less than 0.7 volt. So we know a less than 0.7 volt barrier will not be broken, that will not overcome, and it will not allow the current to flow. But in practical conditions, there will be a very small amount of forward current due to the minority carriers, because there are some minority carriers in the P region as well as some minority carriers in the N region. So there will be very less amount of current in the circuit, and all the voltage will appear across the diode. If voltage is more than 0.7 volt, so forward current will continue to increase. However, voltage will remain across diode approximately 0.7 volt, while current will increase as we will increase the input or bias voltage. So if we summarize, when P side is connected to positive terminal, N side is connected to negative terminal, this is forward bias condition. And the result is that depletion region decreases, barrier potential overcome, and current flows easily. While in reverse bias, this is the condition that prevents or blocks the current through the diode. So now the only thing is the polarity. The bias voltage is applied in opposite polarity, so that minus is connected to P side, plus is connected to N side. And now what happens? Because minus is connected to P side, so this repels the electrons of the N region. Similarly, this positive also repels the holes in P region, and ultimately this widens or increases the depletion region. And because of this increase, the barrier is still increased rather than decreasing. Only there is some current at the starting, at the transient, but after that, because majority current ceases or stops when barrier potential equals the bias voltage. So after that, there is very small reverse current due to the minority carriers, and these are the minority carriers. Just like electrons in P region, holes in N region, they act as minority. So that current is called leakage current, because that is not desired. The diode is only desired to allow the current in forward direction, not in the reverse direction. So if we summarize, a reverse bias, when P side connected to negative terminal, N side connected to positive terminal. The result is that depletion region increases and very small amount of current flows.